Okay, we're going to try this binomial example together. So how do I know it's binomial? Let's read through it. It says a moving target at a police academy target range can be hit 80% of the time. So I either hit the target or I don't. The percentage that they give me in the problem is the P that we discussed in the notes. And then it says, suppose the person takes 3 shots at the target. So the other whole number value that's given to us is our N. So if we go over here and write our notation, this is a binomial model where they took 3 shots and the probability of success on any given shot was 0.8 or 80%. So I want us to think about the difference between the two formulas that were in the notes, right? When we saw the word exactly K successes, and that's supposed to be 2 C's and then an E, we said we were going to use the binom PDF N, P, K. And we fill in whatever number is given for K, we fill it in right here. So now we know that N and P are going to be the 3 and the 0.8. This is very much like when we did normal CDF and we always knew what the first 2 values were going to be. So if this says exactly 2, then I want us to think that this is a binom PDF. There were 3 shots each time, 0.8 probability of success, and I hit exactly 2 of them. And then if you remember from the video, it's okay, Dexter. If you remember from the video, we'd go into our calculator and we go to second bars and we would select, we'd have to arrow up or down several places to get to binom PDF, making sure that we select PDF here and not CDF. And then you go ahead and get your answer, which I believe is 0.384. Now, I'm getting my answers from the solutions, so if these are incorrect, I genuinely apologize. Okay, so if I say misses on all 3, right, then I've not really talked about success in any form here. So that would be exactly 0 successes. So I would do the binom PDF again, 3 trials, 0.8 probability of success, and exactly 0. So if you have a newer calculator, these are entered as trials, P, and then X value or something like that. But if you have an older calculator, you actually have to type in the comma between all the values before you end the parentheses and hit enter. So if you go ahead and stick this in your calculator, you get 0.008. So I have a little trick for when they say something like at least 1, which is a very tricky thing for people to understand. So the way I look at this is at least 1 is 1 or more. So it's literally excluding everything except 0. So we would want to think of this as 1 minus the probability that there are no successes, which is actually 1 minus the probability we just found in the previous example. So the answer here is the complement of the previous problem, which is 0.992. Okay, so finally, let's see, D. The second shot is a hit. Second shot, this is a location that is known, right? It's not saying like 2 shots, which is like exactly 2 hits, right? It's saying I know it's the second shot and I don't know anything about any of the other shots. So this is like a trick question where they just want you to enter the probability of success. Thinking like this could be phrased, what is the probability the first shot is a hit? What is the probability the second shot is a hit? And then finally, I also could have asked, what is the probability the third shot is a hit? These problems end up tricking people because of the language that's used. So let's think about the difference between E and F with respect to D here. E says the third shot is the first shot made. Well, that means that I first had to miss the first, right? Miss the second, and then I made the third shot. So if we're thinking in terms of what we learned in our notes, P is the probability I make it, and Q is actually the probability I don't make it. So what this is Q times Q times P. And I'm going to go ahead and fill in the P first because we know that it's an 80% chance that we do make it. And I want to go ahead and remind you that Q is equivalent to 1 minus P. So over here on the side, I'm going to go ahead and find that Q is 0.2. So we'd multiply these values together, and we actually get, and I'm of course like, my handwriting's way too big, and we get 0.032 for part E. So this is just like a side note, right, to find Q, but this is always true. And this was in our binomial notes. All right, this is also different wording. This is like the first, I get it, you want to go outside. This is like the first 2 shots are hits, but we don't know anything else about the other shots, and they're not really relevant in this case if they don't mention them. This is like I made it, and then I made it, and then I could care less what happens after that. So I would take the probability, oops, I want to write this in the P's and Q's first. I would take the probability of success times the probability of success. So that'd be like 0.8 times 0.8, which gives me 0.64. Okay, so that's my first example, but we only used the binom PDF, right? And the concept of, in these cases, this is actually, let me try to turn the iPad on the side and try to write this way, the multiplication rule. Okay, I totally spelled that wrong, but it's the multiplication rule right there, okay? In my next example that I do in the follow-up video, I will do the second problems, which involve, should be number 6 and 7, and they involve using the binom CDF. So you'll be able to see that as an example. Keep watching.